Now you know about the seasons and what causes them, the Earth's axial tilt. But what do the seasons have to do with how the sun appears in the sky? That's what we'll discuss in this video.
So here we have a model of our Earth-Sun system. We have our Earth tilted at the 23.5 degrees described in the video on the seasons. We have a sun producing light coming in nice parallel rays towards the Earth. Now we're going to look at how the Earth's axial tilt and its motion around the sun impacts how the sun appears in the sky at different times of the year and at different places. So here we're beginning with our Earth at either the spring or the fall equinox. So the Earth is face on, the tilt is sort of up and to the left like this. It's not the summer solstice in the northern hemisphere, which would be like this, nor is it the winter solstice in the northern hemisphere. This would be the southern hemisphere summer solstice. No, we're going to start on an equinox when the sun is, as you can see here, directly overhead on the equator. We can tell it's directly overhead because our stick is not making any shadow. Now, let's pretend that instead of being on the equator, we're here on the Tropic of Cancer at 23.5 degrees north latitude. We can see from the little shadow that the sun is not directly overhead anymore. Since the shadow points towards the North Pole, we can conclude that the sun must actually be slightly south of directly overhead. If you draw out a diagram, you can quickly see how all the different angles work in this situation. If we are instead at 45 degrees north latitude, we see an even longer shadow than we did on the Tropic of Cancer at 23.5 degrees north latitude, which implies that the sun is even lower in the sky from our perspective than it was on the tropics. Finally, if we were near the North Pole, we can see that the sun is basically at 90 degrees. Our entire stick is illuminated all the way to the bottom. The sun is right at the horizon, and so it is 90 degrees south of straight overhead, right on the horizon on this day. Of course, everything we've been talking about is only true on the spring and fall equinoxes. Only on these 2 days is the sun directly overhead on the equator. Only on these days will a stick on the equator not have a shadow. Here's another day of the year to illustrate the point. Here we're looking at the winter solstice in the northern hemisphere, aka the summer solstice in the southern hemisphere. The day of the year, which is the shortest day of the year in the northern hemisphere and the longest day of the year in the southern hemisphere. We can see that on this day, because of the Earth's axial tilt, the sun is not directly overhead on the equator. A stick on the equator generates a shadow that points north. In fact, on this day, it is a stick on the southern tropic, the Tropic of Capricorn at 23.5 degrees south latitude, that generates no shadow. So on the solstice in December, the winter solstice in the northern hemisphere, summer in the south, the sun is directly overhead on the Tropic of Capricorn at 23.5 degrees south latitude. And the reverse would be true on the June solstice, the summer solstice in the northern hemisphere and the winter solstice in the southern. On that day, once again, a stick on the equator casts a shadow indicating that the sun is not directly overhead, while a stick on the northern tropic, the Tropic of Cancer at 23.5 degrees north latitude, casts no shadow. So to summarize, in this video, we've seen that the position of the sun at noon, the highest it gets in the sky, actually is not straight overhead, most places most of the year. In fact, on the spring and fall equinoxes, the sun is directly overhead on the equator, and at any point north of the equator, the sun will be to the south of straight overhead, and Styx will generate a shadow.